Hello, everyone, and welcome to a short presentation called The Evolution of Sinker EDM, sponsored by Graphel Carbon Products. My name is Ken Dworznik. I am the Midwest Regional Sales Manager for Graphel Carbon Products. I've been involved with the graphite industry for 13 years. I'm also a host of EDM Talk on 7 different podcast platforms that talks about electrical discharge machining. Today, I will be talking with Jeff Kiszonas, the Southwest Sales Manager for Graphel Carbon Products. Jeff has been involved with the graphite industry for over 22 years. Jeff today is going to talk about the evolution of the Sinker machine, talking about the history of the Sinker machine to what the technology is today. Jeff, thanks for joining us today.
Thank you, Ken. It's a pleasure to be here.
Jeff, if you can, talk about the beginning of Sinker machines and what were some of the characteristics of the machines 50 years ago.
Well, the Sinker machine for commercial use of electrical discharge machining, it was basically the first one introduced in the 1950s. These early machines, 1950s into the 1960s, they were pretty crude circuits, a lot of arcing and pitting. The operator basically had to know what he was doing by changing settings on the control and stand there at the machine to make sure things didn't go badly. Most of those machines ran hydraulic Z-axes, which were extremely accurate. They used a hysteresis system for balancing the Z-axis and holding it in position. They were only plunge-style machines back then. There was no orbiting. After a little while, before NC machines were introduced, there were a couple of devices that were added to the lower end of a Z-axis on a Sinker machine. And these would allow the machine to do an orbit pattern that the machines today do just through their computer controls. Most of the machines, when they first were introduced in the early days, were designed specifically to run copper electrodes. These machines were designed in Europe, and in Europe, they don't like graphite. It creates too much dust. Things are very close together in a lot of the cities in Europe. Noise is bad enough. So they always did copper and always shied away from graphite. That's changed over the years. Electrodes back then were all sized differently for each different finish that you were going to achieve with that electrode. So in other words, you would have 5 different electrodes to go from your rough to your final finish, but each one would be undersized differently for the different power settings because you didn't have that orbiting capability. The mechanical orbiters, again, helped resolve some of that, but even those had some minor issues, such as when the mechanical stop would engage, it may kick 1 or 2 tenths to one side, which would be enough to possibly scrap an extremely small mold back then. But those were the early machines, and they had some very great limitations, but for what they were really, really high technology of the day.
So, Jeff, following the beginning stages of the Sinker machine, things really seem to progress with these machines. Talk about what movement control added to Sinker machines, and what are some of the new technologies for these machines?
Well, again, the early machines had the mechanical orbiters that were developed. Once you got into the NC and CNC programmable machines, now you were able to control all the axes and the orbit patterns using the X, Y, and Z axes combined. Whereas the orbiter was just a straight plunge down, it would hit a mechanical stop, and then it would start moving until it moved to its program, which was a mechanical analog setting. With the conversational programming of the machines, it is very easy to program most modern machines. They originally started, again, with NC, with paper tape, with G and M code, and it's since gotten very, very simple. So even somebody brand new on the shop floor can be trained probably in half a day on how to write a program for a Sinker EDM. Also, the technologies that were developed. I mentioned the early machines were designed specifically to burn with copper. All the modern machines today, you're going to find technology tables for graphite, for copper alloys, for aerospace alloys, both electrode and workpiece. So it's not just limited to copper to steel or graphite to steel. There are also specific technology tables for burning titaniums, for burning high nickel alloys, for burning carbides. So the technology of the spark settings themselves has greatly advanced. And then today, the most modern machines are using a Windows-based control or something like Windows. Extremely user-friendly, extremely capable, extremely powerful equipment. And again, this is to be able to take novices, apprentices, people who really don't know the EDM process, but to take them to a machine that is so user-friendly, they can still write a program to do a good solid burn and not scrap parts.
If that's a lot of advancement in the EDM machines. I know you talked about some of the advancements in technology. Are there other upgrades that are involved with Sinker machines, and where do you see the future going with these machines?
Well, along with the technologies and orbiting capabilities, and by the way, most of the machines today not just orbit, in around the X plane or around the Z. You could take a compound angle and orbit around a point there. Safer erosion settings at very high settings. There's better circuits and improved generator settings that monitor the spark gap and give constant feedback to the system to let it know if something bad is happening. I mentioned the more diversified settings libraries for different alloys, carbides, things like this. Makes the machines extremely versatile. You could go, for example, from burning a mold insert, if you're a job shop, to burning an aircraft engine part of Inconel, and then switch over to maybe trying to burn some carbide for another customer. So just diversification across the line on one base. Fewer electrodes are needed because of this. Because of the orbiting capabilities, you make all the electrodes the same undersize. That makes it easier for the machining of the electrodes themselves. And then, of course, all the machines today can use graphite. They can all use copper. They can all use copper tungsten. They have settings for all of this. Automatic tool changers. You can get anything from a 4-position shuttle changer on a small sinker to how many positions do you need on that major tool robotic system. I have seen shops around the country that would have as many as 12 to 14 or 15 fully automated Sinker EDM cells, where a robot will actually feed blanks of graphite to a mill, take it from the mill, feed it to the sinker. So the milling machine is making the electrodes. The robot is feeding those electrodes to the sinker machine to make the parts. So lots of advancements like this. Where do I see Sinker EDM going in the future? It's hard to say. It's every time some new technology comes out, it can take away from Sinker EDM applications, high-speed machining. Sinker was used extensively in things like die casting, large forming molds, things like that. It's almost non-existent anymore. All of that is done with high-speed machining. I see the same thing happening with additive machining of whatever nature. The more they can perfect the additive machining to get tighter tolerances and better finishes and crisper details, that's going to take away from EDM down the road as well. I don't think it'll ever go away completely, but as new technologies are developed, I think it's going to take away where EDM is needed and used.
Jeff, outstanding information. Appreciate your time today on the evolution of the Sinker EDM. We look forward to speaking with you very soon on another topic called when to use specific electrode material. Look for this presentation in the next month. Jeff, if anyone is interested in learning more information on this topic or has questions about EDM, how can they reach you?
You can reach me, obviously, through the Graphel website, www.graphel.com. You can use my email address, jeff.kiszonas, that's Kiszonas, @graphel.com. You can also reach me on my cell phone at 480-510-4146.
Jeff, thank you once again for your time. We look forward to talking to you very soon.
Thank you, Ken. Look forward to it.
Thanks for watching this presentation sponsored by Graphel Carbon Products. Please visit our website, www.graphel.com, for more information on EDM and other graphite applications. For Jeff Kiszonas and myself, Ken Dworznik, have a great day.